Good morning, everyone, and our project advisor, Ajahn. My name is Chayut Songpasha. These are my project member, Mr. Pitawat Yapom and Mr. Pongpak Tengtin. We are first-year students from Faculty of Civil Engineering. Have you guys ever wondered what we are going to do when the severe accident is occur while we were using the public transportation, for instance, the SkyTrain or Metro, that we have to exit into their building? And how can you know you will be safe when emergencies and here's come our project title, Development of Simulation Model for Emergency Evacuation from MRT Chatuchak Station. Topic to be covered today is Introduction, Simulation and Model, Process of Simulation and Process of Project. We are going to talk about PTV Viswalk and results, model, developed model, and lastly is conclusion. Okay, let's start with the introduction. I am going to tell you guys about the background of this project. To be honest, we did not intend to study this topic at first. Our project idea was the study of routing and queuing analysis simulation, but we had a chance to meet the head director of MIT. He clearly specified to us that the topic was not what they want. They want some idea that can be able to develop and use in the real situation. So we study of other kind of simulation and what we found. There are not much of this kind of simulation, which is the evacuation simulation. This is what they want us as well. Therefore, they gave us the drawing of MRT Chatuchak Station. Our objective in our group, first we develop and then we make the recommendation. For the scope of the project, first we create and analyze and then we simulate the emergency evacuation and then we measure the time of emergency evacuation with the full capacity of passengers.
For Part 2, Literature Review. Many evacuation models have been proposed in the literature. Evacuation models can be used when assessing and analyzing different types of risk-reducing actions, such as improvements of a building fire protection design and to evaluate their suitability. For our project, we focus on the evacuation in the subway. Occupant evacuation in the subway is often manifested in group behavior. The design idea for the evacuation simulation model is before the evacuation begins. Occupants are distributed in the train compartments, subway platform, lobby floor, stairs, and so on, with some persons standing still and some about. Evacuation begins at a particular time. Evacuees leave their space and transfers to a safe place outside the subway exit through evacuation routes of railway platform, escalators, stairs, lobby floor, and subway exits.
Okay, let's move to the methodology. We start from the whole process of the project. Firstly, we study about an emergency evacuation situation, then we learn how to use the program, which is PTV Viswalk, so we can simulate the situation. And the last one is to conclude and analyze the results. So we're gonna move to the PTV Viswalk program. What is PTV Viswalk? The PTV Viswalk is a microscopic pedestrian traffic simulation tool, whether simulating pedestrians along urban roads, passengers transferring in station, occupants escaping from a building or visitors of a festival. PTV Viswalk program also allows you to simulate pedestrian movement. There are totally four main tools that are used to construct the model, which are levels, area, obstacles, and pedestrian inputs. For the results, it is divided into two parts, which are the results from an original model and developed model. For an original model is built as same as the real station. In this case, we use draft paper from MRT to construct the model. And this slide shows an overview of a simulation model. There are 4 floors in total, which are platform, concourse, retail, and ground surface level. These are the escape time results. The table on the left-hand side shows the escape time from the platform level to safety point or ground surface, and the table on the right-hand side shows the calibration test of an escape time from platform level to concourse level. Both tests are measured for 10 times, and the average escape time are 9.082 and 3.29 minutes, respectively. From an observation, the high volume of pedestrians occurs near the gates at concourse level here, so this point makes a delay and disturb the flow of traffic. Our idea is to solve this problem in a developed model.
So far, in the developed model part, we consider the flow of the original model and clarify what the problem is in this evacuation simulation. The previous slide showed you the bottleneck in this station when the evacuation is simulated. To develop this simulation, we expanded the walkway, as you can see in the picture that we show you right here. This slide also shows you the both perspective view at the area that we expand. I'll show you guys again how different in the flow of evacuation between the bottleneck and the developed model. As I said, the developed model has a high flow. If we compare between bottleneck and the developed model over here. For the test results, the developed model 1 show you the escape time of developed evacuation model. As you can see, the escape time are around 8 something and the average is 8.309. In this slide, show you the another developed model. The difference between developed 1 and 2, we change the escalator to stairway because we're gonna make sure that if the escalator were not the safest way to escape, so we change all of the ramp to be stairway. But as you can see, that's a bit different in timing, but it is too little because the deviation still be the same as the developed model 1.
For Chapter 5, Conclusion and Recommendation. To sum up, an original model takes longer time to escape to the safety point during evacuation, which is equal to 9.008 minutes, as the model was constructed from draft of real MRT station without any improvement. For developed models, the first model is remove barriers at concourse level and replace them by other two gates. These gates increase the flow of traffic and then decrease escape time. The second developed model is as same as the first model, but this one turns all of escalators into regular stairs in order to observe pedestrian behavior in different conditions. After performing and running the program, the results of an escape time for both cases are quite similar. The escape time of them are 8.309 and 8.311 minutes, respectively. For recommendation, based primarily on the simulated model, if there were to implement points of improvement to MRT Chatuchak station, replacement of barriers by gates, with the intent to decrease escape time during evacuation. Since the simulated model was constructed to mirror an actual station with similar parameters regarding paths and pedestrian capacity. Therefore, the result from the simulation could be compared and superimposed on the actual station. Generally, there are arguably more effective ways to improve the model, such as extending the width of stairs. However, it is feasibly difficult to alter staircase dimension. Therefore, the method mentioned in the trial model simulation that replace the barriers with gates is the easiest and effective way to improve evacuation time and possibly enhance safety procedure while allowing for larger margin of errors. Thank you for your attention.